All right, let's talk about breaking the rules. And I mean the biggest rule of them all, cause and effect. Today we're jumping headfirst into the grandfather paradox. It's this mind-bending puzzle that basically puts time itself on trial. And we're going to explore how the universe might actually have a few tricks up its sleeve to solve it.
So picture this, right? You finally do it. You build a time machine. You hop in, go back in time, and you stop yourself from ever being born. But wait a second. If you pull that off, then you never existed to build the time machine in the first place. So who the heck just stepped out of that machine? Yeah, that is the classic brain melter we're digging into today.
And look, the really key thing here is that this isn't just some fun little story. It's a full-on assault on causality. You know that basic rule that says an effect has to follow its cause. If you can just pop back in time and get rid of your own cause, well, the effect, that's you, should just vanish. And when that happens, it feels like the universe's entire operating system just crashed.
Okay, I know you're thinking, this is all just sci-fi, right? Well, here's the crazy part. Physicists actually take this stuff seriously. Why? Because the rulebook for our universe, I'm talking Einstein's theory of general relativity, it actually has loopholes that could allow for this. And the name for that loophole, that theoretical gateway, is a closed timelike curve.
So what on earth is a closed timelike curve? Well, it's pretty much what it sounds like. It's a path through spacetime that literally loops back on itself. You follow it, and you end up right back where and when you started. It's a genuine time loop. And Einstein's math suggests these things could exist in some really wild places, like maybe around a super fast spinning black hole or inside a wormhole. And that's the scientific back door that turns the grandfather paradox from a fun thought experiment into a real headache for physicists.
So, if the laws of physics leave the door open for these time loops, how does the universe stop itself from just completely breaking? How does it prevent this total chaos of contradictions? Well, physicists have come up with three main ways the universe might be able to fix the problem and keep everything making sense.
So let's break them down. We've got the enforcer, which basically says the past is locked down. Then there's the escape route, which suggests you can create a whole new timeline. And finally, the tiebreaker, where the weirdness of quantum mechanics comes in to save the day.
Okay, so our first fix is called the Novikov Self-Consistency Principle. And the idea is actually pretty straightforward. The past is set in stone. You can't change it. If you go back in time, you don't get to rewrite history. You actually become a part of it. Your actions were always supposed to happen. It's like you're not rewriting the movie script. You're just finally showing up to play the part that was written for you all along.
To really get this, let's look at a classic example. Imagine a billiard ball, and it's rolling straight for a wormhole that's basically a time machine. Now, if it goes in, it's going to pop out a few seconds in the past on a perfect collision course with its younger self. It'll knock itself off course so that it misses the wormhole entirely. So wait, if it misses, it never went in, which means it couldn't have come out to knock itself away. See? A perfect paradox. Or is it?
Well, with this enforcer rule, that's not how it plays out. Instead, the future billiard ball comes out of that wormhole and gives its past self a perfect little nudge, just a tiny glancing blow. It changes its path just enough so that it still goes into the wormhole and on the exact path it needed to be on to come back and deliver that exact same nudge. It's beautiful, right? There's no paradox at all, just one perfect, stable time loop.
Okay, so let's put that idea up against our second fix, branching timelines. It's a totally different flavor. With self-consistency, you've got one single unbreakable timeline. That's it. But with the branching timelines idea, your actions in the past literally split reality in two. You don't change your history, you just create a brand new parallel universe. So yeah, in that new universe, your grandfather never meets your grandmother, but back in the timeline you came from, everything's totally fine, completely untouched.
And that brings us to our third fix, which is where things get really, really weird, because we're diving into the quantum world. This idea comes from the physicist David Deutsch, and it suggests that the universe itself plays referee, using probability. It basically forces what you could call a probabilistic stalemate. So how does that work? Well, it's wild. Basically, any action you try to take that would create a paradox, its chances of success get automatically dialed down to zero. Think about it. You go back in time to try to kill your grandfather, but the quantum odds of the universe would all conspire against you to make sure you fail. Maybe your gun jams, maybe you trip on a rock, maybe a bird flies in your way at the last second. The point is, the universe itself would force a consistent outcome by making the paradox literally impossible.
Okay, so this is all a super fun puzzle, right? But you might be wondering,
Is this just a game for sci-fi fans? Why on earth do actual physicists spend time on this? Well, it turns out that wrestling with this paradox is how we push the absolute boundaries of science. It has some surprisingly real-world implications.
Think of it like a stress test for our biggest ideas. When we push our theories to their breaking point with puzzles like this, we learn where the cracks are. It helps scientists work on quantum gravity, the holy grail that's supposed to unite Einstein's universe with the quantum one. It makes us get really precise about the rules of cause and effect. And get this, it's even inspiring new ideas in quantum computing where a theoretical time loop could potentially solve problems that are impossible for any computer we have today. It's a genuine tool for exploring the deepest rules of reality.
All right, so this all leads to a really big question, and it's kind of a myth buster. So many movies and books just assume that if you go back in time, paradoxes are just going to happen. It's inevitable. But is that really what the physics tells us?
The answer, surprisingly, is a pretty hard no. I love this quote, "Physics is bossy." And it's true, the fundamental laws of the universe, things like conservation of energy or just basic quantum consistency, they would almost certainly force a time traveler to play by the rules. They'd put guardrails on your actions to stop a paradox before it even starts.
So you see, the paradox doesn't actually break physics. What it does is force physics to show its hand. It forces us to ask, what kind of reality are we actually living in? Is it one single unchanging story? Is it a multiverse with endless branching timelines? Or is it a universe where the quantum rules are always the final umpire, making sure nothing gets out of line? And that, right there, is the biggest takeaway. The grandfather paradox, it was never really about whether you could change the past. It's about understanding the very nature of our reality. Are we living in a universe that protects its history, that locks down one single story for all time? Or do we live in a universe that's constantly creating new histories, embracing an infinity of possibilities with every single choice we make? That's the real puzzle. And that's what makes this whole thing so incredibly cool to think about.